And then we start plotting things down. Okay, so what do you notice about how I started out with the graph? Sorry? Label. What else did I do? The most important thing on a graph. Well, that's the label. Well, it's not number. What do you call it? Sorry? You scale it. Yesterday's test, people didn't scale it. Points taken off. Yeah. I mean, you've been with me for 8 months now. Okay. You should know these things. I mean, a graph without a scale is totally useless. Okay, totally useless. Okay, let's put down the center. Where's the center at? 0, 0. So let's go put that down. So here's my center. So A is going to be, which direction is A going to be? X or Y? X or Y? Y, Y. Where's A underneath? Always underneath the first variable. Whatever the first variable is, in this case it's X. Okay, so it's going to be, so your vertex is going to be 2 units from the center. So here's your vertex 1, here's your vertex 2. Okay? And then your foci are going to be 2 root 5 units away, right? So your foci are going to be closer to the center than the vertexes. So 2 root 5. No, wait a minute. Did I smoke on this one? No, it's going to be further away from the center, right? 2 root 5. Root 5 is about 2 point something, so it should be 4 units or so. So here's your focus 1, and here's your focus 2. Okay. Now don't go and throw in your hyperbola at this stage. What you need to do next is do this, step number 4, before you start drawing in the hyperbola. So to draw the asymptote box, okay? So here it is. Since the hyperbola is oriented horizontally, A is going to go in this direction and B is going to go in that direction. Okay? A is horizontal, B is vertical. What you're going to do is you're going to go from the vertex, you're going to go B units in the Y direction. What is B equal to? 4. So you're going to go 1, 2, 3, 4. Right there. 1, 2, 3, 4. Right there. And you're going to do the same thing at V2. A corner there and a corner there. That defines your asymptote box. Okay, you with me on that? And then you get your asymptotes out of there. And asymptotes are always drawn in dotted lines, okay? Because they're not really part of the graph. Okay? And then you graph your hyperbola. You know it's going through the vertices right there and there. So it's go to asymptote. Don't you like these colors, man? Look at this. It's awesome. Isn't it nice colors and everything? It looks a little ugly, though, I feel. It looks nice on the screen here, but it doesn't look all that pretty out there. Okay? Now, the real question is, how do you find the equations of the asymptotes? How do you find this equation? Sorry? That memorizing thing? Well, what if I don't want to? Like I'm saying, my memory is decaying very rapidly. I have a feeling I'll have no memory by the end of summer. Why? You know it's a line. In this case, the line is going through the origin. Yes? So it's got to be y equals mx type. Am I right? At least this line here, the one that's got a positive slope. Okay? And the slope's going to be rise, which is b in this case, and b is equal to 4 over run, which is a in this case. A is equal to 2. Rise over run, so y equals 4 over 2x, which is equal to y equals 2x. Okay? So if you don't want to memorize, you can go about deriving it. Okay? Now it might happen that it doesn't go through the origin. Well, no big deal. It's going to go through the center of the hyperbola anyway, and you have to find the center out anyway, right? Right there. You guys with me on that? Because it's 4 over 2. 4 over 2 is 2. Okay, you go to reduce. If you don't reduce, I'll take points off as well. Okay? Is everybody all right, Sujal? Good? Okay, next example, I have a feeling you might have to do it. Oh no, eccentricity. Well, you won't believe it. Someone on the test yesterday was asking me, what does eccentricity mean? That's sad. That's sad. Hell no. Okay. No, you know, I don't get mad. I try not to get mad. Okay, so, do you know, Myra, what eccentricity is? C over A. So you can see that here is C, and here is A. Can you conclude that C is always bigger than A for a hyperbola? So what can you conclude about the eccentricity? Always greater than 1, right? Greater than 1. Because C is always bigger than A. So if your numerator is always bigger than the denominator, the answer's got to be more than 1. Guys with me on that? Okay, so for hyperbola, the eccentricity is always more than 1. Do I have another? Oh, that was it? End of day 2.